So continuing what we were discussing earlier, we have solved the symmetric functions in respect to the two roots of quadratic equation. Now further we are going to discuss, and we have also driven how these statements and these results were coming true. So the derivations were also clear, and we have also solved one example. Now coming to next topic, which is the graphs of quadratic equation. As we know, if we consider like these quadratic equation as curves, if we try to represent them on a xy axis graph, that is a 2D Cartesian plane. So as we know, it's a second degree polynomial which will form a parabola. So let's first understand it will form a parabola, and parabola can be. And as you know, parabola can be drawn, or like there are four kinds of parabola: upward facing, rightward facing, left hand faces, downward facing. Okay. But and as well as parabolas can also be situated at different locations. But now in the case of quadratic equation, uh, as the equation will look like this. So we are going to look on two cases. The parabola will be upward or downward. Upward in the case of a being greater than 0 means positive, and downward being a less than 0. Okay. And there is also one more case. This is about how the parabola will be situated with respect to the x-axis. Now let's talk about where it will be positioned on y with respect to y. So this is going to intercept, the parabola is going to intercept the x-axis only when there are roots. Like, say this is the graph. Okay. So let's bring the parabola from the previous page. So this is the parabola. Now this is going to cut the x-axis only, or even touch the x-axis only if there is a solution existing which is real, like only if the real roots exist. And as we know, real roots exist only for the positive discriminant quadratic equation, or the discriminant being 0. So there are only two cases in which the parabola will be touching the x-axis. And in this case, particularly when the parabola is touching on one point only on the x-axis, so this means that the roots are real and coincident. Coincident means the roots are same. And this happens in the case of when discriminant becomes 0. Okay. Now, if the discriminant is positive, means it is greater than 0, then what will happen? Then roots will be real, yes, of course, but roots will be different in that scenario. Okay. So now if the roots are different, so there will be how many roots? Two roots, because of quadratic equation. So now the parabola is going to touch the x-axis on 2 points. So rather than being positioned like this, it will touch the x-axis on 2 points. Say these will be two roots of the quadratic equation. And we have considered that the coefficient of x square in the quadratic equation is positive. One more case is left as we are discussing about discriminant. So what if the discriminant becomes negative, like less than 0? Then what will happen? If discriminant is less than 0, then roots will be imaginary. They will not exist. So there will be imaginary roots, and yes, there will be different roots. Okay, a plus minus beta. So in that particular scenario, the parabola is not going to touch the x-axis anywhere. It's going to lie above the x-axis or down in the case of when a is negative. So it's going to be look like this. And for a being negative, this is how the parabola of quadratic equation, the curve is going to look like. This is particularly for a being negative and discriminant being negative. Okay, so let's now discuss about particular graphs in different situations. So now for a being positive, like that is greater than 0, so the graph is going to be in upward form. It can like touch the x-axis or intersect or even do not touch. So let's write this in this format only. And for a being negative, for a being less than 0, so the parabola is going to face downwards. It can be positioned anywhere. That will depend on discriminant. Now, when the discriminant is positive and a is also positive, the discriminant is positive, means that there will be two real roots and they will be different. So it is for sure that the parabola is going to touch the x-axis on two different points. And a is also positive. That means the parabola is going to face upwards. So now we have the picture that what the graph should look like, because here it is facing up. The parabola is facing upwards, and there are also two roots. Like why two roots? Because the curve is intersecting the x-axis twice. When we discuss about discriminant being 0 and a being positive, so a being positive, the parabola will be facing upwards. For discriminant being 0, there will be same roots. There will be coincident roots. So the parabola is going to touch the x-axis only once. So the parabola will be positioned in this manner. Okay. Now for discriminant being 0, so that means the parabola is going to touch the x-axis only once, and a being negative, a being less than 0, so the parabola is going to face downwards. So we can have the parabola inverted and touching the x-axis only once. Now the discriminant is less than 0, negative means imaginary roots. The parabola is not going to touch the x-axis anywhere, and a being positive, so the parabola is going to face upwards. So something like that. Now discriminant is negative, a is also negative, so the parabola is not going to touch the x-axis, and for a being negative, the parabola is facing downwards. Not touching anywhere. And here also discriminant is negative, so not touching anywhere, and a is negative. Sorry, discriminant is positive this time. So this is going to intersect the x-axis twice, because the discriminant is positive and it is also more than 0. So there will be two real roots and two different roots, and a being negative. So that's why the parabola is facing downwards. Now let's discuss about the maximum and minimum value of quadratic equation ax square plus bx plus c. So considering that, let's look at this graph only. Okay, let's look at this graph only and take this slide now. So if we look here, so this was the case when the value of a, the coefficient of x square is more than 0, that's positive, so the graph is facing upwards. So if we look at the value of f of x, this is f of x, this is x. So f of x is minimum for this particular curve. Yes, there f of x is minimum for a certain value. And fx has certain minimum value. But when we look at the maximum value of fx for the quadratic equation, in the case when a is positive, so there is no such limit because it's tending towards infinity. So what we'll say, quadratic equation ax square plus bx plus c is equals to 0. So its maximum value, sorry, not equation. We are discussing about the function. So its maximum value, its fx is going to its maximum value is not defined. And yes, there exists a minimum value of this function, and which we will find out soon. But let's first understand about the quadratic this function ax square plus bx plus c, where a is less than 0. So when a is less than 0, this particular graph, have a maximum value here. But there is no minimum value because it's tending towards infinity. So the function's minimum value is not defined. And when we talk about functions maximum value, its maximum value is defined, and we are going to talk about it soon. Okay, so if this is clear, let's go ahead and discuss about the function, which is f of x equals to ax square plus bx plus c. As we have studied about derivatives earlier and also the derivative test, so we are going to find out this particular curve's minimum or maximum value. First, we need to derivate this on both sides with respect to x, comes 2ax plus b, and plus c's derivation with respect to x is 0 because c is a constant. So now equating this equals to 0 and finding out the critical point. So let's replace x with c plus b because f dash of c is 0. So now minus b by 2a is c. So this is a critical point on which let's now find out. So this is the critical point, critical point. So let's now discuss about the double derivative of this particular quadratic function. Derivating this particular equation both sides with respect to x, f dash of x becomes f double dash of x, and 2ax derivative is 2a. Derivative of b is nothing. So now whether on this particular point c being minus b by 2a or x being minus b by 2a, whether the function is going to assume its maximum or minimum value will depend on the sign of a. Okay, so this is the reason that's why we are looking for the sign of the coefficient of x square for determining whether the curve is going to assume its minimum or maximum value. So as we also know that in let me recap the second derivative test for you. What we do in second derivative test, we first of all take the function and single derivate it, and we'll find the critical point for which the single derivative is becoming 0. After finding c, we also find f double dash of x. After finding c, we substitute x with c, and we see whether if it is positive, then the function is going to assume minima on x is equals to c, and if f double dash of c is becoming negative, then the function is going to assume its maxima, local maxima on x is equals to c. So that's the case. Now here we are not going, if even if we substitute x with c, this still remains 2a, which is dependent on the sign of a. Okay, if a is positive, we will be able to find out the minimum value of function on minus b by 2a. And if a is negative, then we are going to find out the maximum value this time of the quadratic function on same point, f of minus b by 2a, which is the critical point here. So now let's summarize and write for as we're discussing about quadratic equation, sorry, this function ax square plus bx plus c, for a being positive. Okay, for a being positive, the parabola is going to face upwards. So that's why there will be no maximum value. That will be not defined. And when it comes to the minimum value, there will be a certain value on x being minus b by 2a. That will be its minimum value. If we go on to substitute x with minus b by 2a, we'll solve for minus d by 4a will be our answer. Now let me explain how we have done so. Okay, so the function was f of minus b by 2a. Let's try to find out this value. A into x square. So b square upon 4a square plus b into x, that is this, plus c. So now taking a cancels a, taking 4a as LCM. So this becomes b square this becomes, yes, b square minus of b square plus 4ac. Okay, let me recap. B upon 4a square plus b into x, which was minus b by 2a plus c. So this equals to taking LCM as 4a, okay, b square. So this, yes, taking 4a as the LCM. Now 2a divided 4a divided by 2a, which will give us 2. So minus of 2b square plus 4a into c, 4ac. So this becomes 4ac minus of b square upon 4a. Now we can look that this is a particular number which is discriminant. It is minus of the discriminant, minus d by 4a. That's how we have written so. Okay. So there will be a particular minimum value for the function ax square plus bx plus c for its curve, and when a is positive. Okay. Now let's discuss otherwise, that the given function is ax square plus bx plus c plus c, and a is less than 0. Now in this case, discussing about the functions minimum value. So the parabola will be downward facing. So that's why there will be no certain point on which the curve is limited towards the down. So that's why we are saying the minimum value of this function is not defined, because it is tending towards infinity. Okay, now further discussing about the functions, maximum value will be on minus of b by 2a, and which will come out as minus d by 4a. And how so, I have already explained you in the previous slide. So this is about a maximum and minimum value of quadratic of ax square plus bx plus c of quadratic function. And Let's now look for some. Yes, there's a next topic, inequality. So inequality first is like just comparing two things and stating one is greater and one is lesser. So this is about comparison. Okay. So let's understand this sign. So whenever this sign is written, so it means that, let's say there are two quantities, A and B. So this sign is stating that A is lesser than B. And simultaneously, it is also saying that B is greater than A. Okay. So just a trick to remember that wherever the mouth of this symbol is open towards, that will be a greater thing. So now there is also one more thing to consider. Taking more examples of it, like 5 is less than 8, and 8 is also greater than 5. That's one example for this. Now discussing about mixed inequality. In this particular case, it means that A is less than or equal to B. And this particular statement is simultaneously suggesting that B is greater than or equal to A. Okay. So this is about inequality. Properties of inequality. If A, B, and C are real numbers such that A is greater than B and B is greater than C, then A will be greater than C. So let's take one example. If we write 1 is greater than 2, no, that's false. Like 1 is less than 2. Let's take the example in this sequence only. Let's say we know that 4 is greater than 3.5. And yes, 3.5 is greater than 2. So can we write 4 is greater than 2? Yes, we can. So that's the concept here also. This is the property. A, B, B, C. So we have written A is greater than C also. This is kind of a transitive property. More generally, A1, A2, A3, An minus 1, An, these are the real numbers terms such that A1 is greater than A2 greater than 3, A3 greater than A4, and so on and on. So then we can conclude from this that A1 is, of course, greater than An. Okay. Second property, if A and B are real numbers, then A is greater than B. So it implies that if we will add C on both sides, then A plus C is overall greater than B plus C. But there's a condition here that C must be a real number here because inequality is not defined for imaginary numbers. Property number 3, if A and B are two real numbers, then then we can write if A is greater than B, so it implies that AC will be greater than BC and A by C will be greater than B by C. Basically, what we are doing is we are doing mathematical operation. Earlier, what we have done, addition or subtraction operation. Now we are discussing about multiplication or division in inequality. So there's one new change here. If we are doing so, then we need to make sure that the sign, that whenever we multiply or divide any positive number, any positive real number on both sides of inequality, so the inequality sign will not turn, will not change. Here also we have seen that this is the same sign. This is also the same sign when C was positive and positive real number. But when we discuss about uh, when there will be a negative number, when there will be a negative real number here, C is a negative real number. And if it is getting multiplied or divided on both sides of the inequality. So it's going to change the sign of inequality. Okay, it's going to change the sign of inequality. So that's the property. It's important. Why important? Because we do mistake about multiplying, and we, like, most of the candidates are confused. Most of the students are confused about multiplying negative signs and how the inequalities change. So this is the basic of that. Now discussing about the fourth property. If A is greater than B and B is greater than 0, like A and B both are positive real numbers, then 1 by A is less than 1 by B. That's very self-understood. We have done this, that A was greater than B. So we have just cross multiplied 1 by B, 1 by A. And the sign of inequality is not changed. Why? Because A and B both are positive. It was given in the properties statement also. Okay. So now further discussing about the property number 5, which says if A1 is greater than B1, A2 is greater than B2, and so on and on. And it is written that A1 plus A2 plus A3. Hmm. So it is simply that we are adding multiple inequalities. Let me write it separatively. A1 is greater than B1 and A2 is greater than B2. A3 is greater than B3. So on and on. AN is greater than BN. So we may say that we may conclude it in this format that even the sum of all A terms will be greater than sum of all B terms. That's what the property number 5 says. Property number 6. If A1, A2, A3, AN, and B1, B2, B3, BN are positive real numbers, such that A1 is greater than B1, A2 is greater than B2, and so on and on. Every A term is respectively bigger than the B term. So we may conclude that A1, A2, A3, AN, the whole product of A terms will be greater than the whole product of all B terms. That's one inequality. Now, discussing the seventh property. If A and B are positive real numbers, such that A is less than B, and if N is any positive rational number, then A raised to power N is less than Bn, and A raised to power minus of N will be greater than B raised to power minus of N. And C A raised to power 1 by N is going to still remain less than B raised to power 1 by N. So these are the properties. We can take one example. 2 is less than 3, and let's take N is N as uh, N is 2. Okay, so A is 2 raised to power 2 will be less than 3 raised to power 2. So 4 is less than 9. Yes, raised to. Discussing about B.
2 raised to power minus of half, sorry, minus of 2 is greater, should be greater than 3 raised to power minus of 2. That's 1 by 4 greater than 1 by 9. Yes, it is also true. Speaking about property number C, 2 raised to power 1 by 2, that is square root of 2, is less than the square root of 3. Oh, yes, it is true because its value is around 1.41, its value is 1.7. So all the properties are true, are with taking the example also. Now let's discuss the next property. Property number 8. If a if 0 is less than a, less than 1, and n is any positive rational number, then 0 is less than a raised to power n, which is further less than 1, and a raised to power minus of n is greater than 1. How so? Because the base which is a is less than 1. So of course, if you are going to increase its power, the overall value is going to decrease. And also that it is never going to, if the base is positive, so if we raise its power to anything, it's never going to become a negative. Never going to become a negative number. So property A is also true. And when we are going to uh, discuss about when we are going to raise its power to like negative of some positive rational number, like there is a negative power to a, so definitely it's going to become more than 1. Let's take an example. Let's let a be half, let a be half, and n be consider 3. So in the first case, 0 a half raised to power 3 less than 1. Oh yes, it is true. 1 by 8 less than 1. Property number B, half raised to power minus of n, that's like minus 3. It's going to 1. It's going to become more than 1. Okay. So it is what? It is simply, let me write this somewhere. Let's take next page. Half raised to power minus of 3 greater than 1. Of course, if there is a negative power, so we can reverse, write it as like this. 2 raised to power 3 is what? It is greater than 1. Yes, it is true. So both A and B are correct. I hope you are able to understand what the property number 8 says. Discussing about property number 9. If A is greater than 1 and n is any positive rational number. If A is greater than 1, so the base is greater than 1 and n is any positive rational number, then uh, okay, then a raised to power n is greater than 1, of course. If the base is like more than 1 and we are going to increase its power, then it's going to go upward only. We have also discussed about it in the logarithm graph. And if we are going to take its negative power, the negative power means that we are making a as 1 by a. So of course, if we are considering a value which is less than 1, so whatsoever, if you increase the power, then it will still going to remain uh, less than 1. Okay, let's take one example. Uh, Taking a as greater than 1, so let's take a as 3 and being 2. So in first condition, a raised to power n 3 raised to power 2 is going to be greater than 1. Yes, 9 is greater than 1. That's true. B. Z 0 is less than A is was 3 raised to power minus of 2, less than 1. So 0 is less than 1 by 9, less than 1. So yes, 1 by 9 is less than 1. So B is also true, as per our example. So property number 9 is also clear. Discuss about the property number 10. If 0 is less than A, which is further less than 1, and M, N are positive rational numbers. Okay, rational numbers are those numbers which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. So, and then it is said that if M is greater than N, then of course A raised to power N is going to be greater because A, which is less than 1, so if its power it is less increased, then it's going to remain more great. Let me let's take an example. Let's take A is half. Okay, let's take M being greater than N, the first condition. So let's take M as 3 and N as 2. So A raised to power M, half raised to power 3 should be less than half raised to power N, which is 2. So 1 by 8 is of course less than 1 by 4. What is 1 by 8? 0.125 is of course less than 0.250. Yeah, that's the case. Basically, what we need to understand, when the base is less than 1, when the base is less than 1 and it is positive, so whatsoever you increase the power, it's going to decrease. Like its overall, the function is going to decrease only because its base is less than 1. And if the base is more than 1 and its power is getting increased, then of course it's going to increase exponentially positive. Let's discuss about B property. A is half, M is less than N. So M is 2 this time, N is 3 this time. So A raised to power M, which is half 1 by 4, is going to be greater than 1 by 8. Yes, it's 2. So now discussing about the 11th properties, which says if A is greater than 1, A is greater than 1, and M, N are positive rational numbers, then so it's about a function. We are discussing about a exponential function. Okay. So in this case, what is happening is there will be two scenarios. If A is less than 1 and if A is more than 1, greater than 1. So if A is less than 1, on increasing x, f of x will decrease. And in the case when the base is greater than 1, so on increasing x, f of x will also increase. So the same concept, these properties are also based upon. So discussing about the property number 11, if A is more than 1, A is more than 1, and M and are positive rational numbers, then M is greater than N, then of course A raised to power M is going to be greater than A raised to power N. And also when M is less than N, so A raised to power M will be less than A raised to power N. It's self-explanatory. Please take one example of this, taking A as 2 and M and L as 2, and will be able to understand this property more deeply. So discussing this inequality, now for this inequality, we have to find out its domain of x. Okay, for which domain of x will this inequality stay true? Okay, so let's eliminate from the options. If we take uh, any number from -3 to 5, let's take 0, because yes, 0 is in three options. This option as well, this option as well, this option as well. 0 is included in these three domains of x. Let's take whether for 0 this will stay true or not. For 0 this will become -3 greater than 5. So 3 is less than 5. Yes, of course, it's true. So it's sure that the option number B is eliminated. So option B should not be our answer. Now let's take uh, x as uh, now let's take x as 4. So yeah, now let's take x as 4. So 8 minus 3, 9. So it is 5 less than 9. So yes, 4 is included. It means that 4 should, and in this particular given domain, 4 is excluded because 2 by 3 is what? 0.66. And so it's not going ahead of 0.66. And even 0.66 is not in. Option D is also eliminated. There can be multiple methods to solve a question. Let's take x is equals to minus of 1. So on taking x is equals to minus of 1, no, let's take x is equals to minus 2 by 3, because minus of 2 by 3 is excluded in the option number C. So on taking this, become minus 4 by 3, minus of 3, and x plus 5 minus 2 by 3 plus 5. So this becomes 3 minus 2 plus 15 minus 13. This becomes 3. This is what? 4, right? Minus 4 minus 9, this minus 13 by 3. So this inequality is not staying true here because this has become equal. So uh, x is equals to minus 2 by 3 should not be in the domain, which is included in the option number A, because minus 2 by 3 is what? Minus of 0.66. So if it is there in the given period A, so the option number C should be our correct. There's another method to solve this. What they have done is they have taken the inequality from right hand side to the left hand side and solved on further by taking assumptions, where they have made first assumption as x being less than minus 5 or equal to minus 5. So they have rewritten this expression in this format. And how have they done so? Why particularly minus 5? Because they are considering about these two modulus function. These modulus function will be changing sign on x plus 5 being 0. So x is equals to minus 5. And on x, 2x minus 3 being 0, on x is equals to 3 by. So these are the critical points to understand and to divide our given domain. So there are two functions for different domains. Now they have further gone on to solve these inequalities and find out its value. So it can be also done in this manner, and also the options can be eliminated. Now discussing about arithmetico-geometric mean inequality. Uh, yeah, it says that if A and B are positive and A is not equals to, then A plus B by 2 is greater than the geometric mean of 2, and which will be greater than the harmonic mean of 2. So this is what arithmetic mean of A and B, and this is geometric mean, and this is harmonic. Okay, we will better understand it in the chapter sequence and series. But that's one very important inequality which can be used in multiple questions. And even there are a lot of questions on the property using the arithmetic mean of two numbers is greater than the geometric mean of those two. Now let's discuss about the second property. If the AI's term is greater than zero, so it's like positive, where I is 1, 2, 3 to n terms, and there is given that this is arithmetic mean, which is greater than equal to geometric mean, which is greater than equal to harmonic mean. Okay. So there's a equality condition here included. Why? Because we have not said that the A1, A2, A3 are not equal terms. And and if they are equal, then arithmetic mean, geometric mean, and harmonic mean, they are all going to become equal. Okay. So let's now discuss about this inequality question example. If A, B, C are three distinct positive real numbers, so they are positive, real, and distinct. So now we have to find out about its inequality. So A plus B plus C, and so let's now understand the fact that the arithmetic mean of all these three will be what? A plus B plus C by 3. And the harmonic mean will be what? 3 upon 1 by A plus 1 by B plus 1 by C. So we know arithmetic mean is greater than harmonic mean if if they are different. Yes, they are different in this case. Distinct positive real numbers is the given condition. So arithmetic mean is greater than harmonic mean. Cross multiplying, as they all are positive numbers, we can cross multiply easily. 3 into 3, 9. So A should be our answer. Absorb. So let's now move ahead. They have also gone for the same approach where they have made arithmetic mean greater than geometric mean. The arithmetic mean formula for three numbers ABC is A plus B plus C divided by 3 greater than ABC multiplied and whole to the whole power 1 by 3. Now discussing the next example. Here, four real positive numbers, they're real positive numbers A, B, C. We have to find out the minimum value of this. So how we can understand it better? B plus C divided by A. So let's take LCM. A, B, C will be around LCM. So BC will be divided by B plus C, and AC will be divided by C plus, sorry, multiplied to C plus A, plus AB will be multiplied to A plus B. Now that we discuss about it, it's one thing which is for sure that let's take this term only. Okay, let's take this term only. What is A plus B by 2? It is greater than or less or equal to the geometric mean. Okay, so okay, okay. Approach this different. You have to find out its minimum value. Okay, so let's solve this further. Let's write it in a better manner. A square b plus ab square plus ab square plus cb square. This is done, this is done, this is done. Yes, good evening.
Good evening, sir.
Yeah, is my voice audible?
Yes, sir.
Okay. So this term is done, this term is done, and this term is also done. Wait, we are making a mistake. Here, c b square plus c square b should be here, and ac square plus a square c will be here. Should be here. Yeah. So Yarini, we are discussing about inequalities, and the basic concept of solving these examples is this property that arithmetic mean is greater than or equal to geometric mean, which is greater than equal to harmonic. And the formula of the same is given.
Okay, sir.
Okay,
Yes.
so so uh, let's consider some terms. As, so b plus c divided by a. If we find out its minimum value, and then if we can like apply the same method and analogy on other three terms also, we'll be able to find out its answer. So we know one thing is that b plus c divided by 2 is uh, is less than, sorry, b plus c divided by 2 is greater than its harmonic, which is 2 bc upon b plus c. Okay, so writing it, how we can write it further, b plus c whole square is greater than 4 bc. Now let's expand this format. B square plus C square plus 2BC, which is greater than 4BC. Now B square plus C square, this comes to the left hand side, and 2CB greater than 0. Now going to the next page, we can write B minus C whole square is greater than 0. Okay, so on taking square root on both sides, from this, yes, it is an evident equation is an evident equation of inequality that anything square is always going to become uh, more than zero. That's positive. So that's of no use. So let's now discuss about this term. Let's refer to solution better. Okay, so that was just better representation of x. They have what they have done. What they have done is they have separated the given equation of b plus c. Okay, b plus c divided by a plus b divided by c plus a plus c divided by b. So they have written it like b plus a plus c by a plus a by c plus b by c plus a by b plus c by b. Now there are these six different terms. So okay, now you are able to understand that this is the arithmetic mean and this one is the geometric mean. So geometric mean in this case is becoming 1 because is like this. That's why it's becoming 1. So 6 is going to the right hand side. Inequality sign is unchanged because 6 is a positive number. So now they are able to find out its minimum value, which is understood. And what we were missing earlier is we were not uh, we didn't represented it correctly. It was tricky question, which is based on observation. Understood?
Yes, sir.
Okay. Okay, so the almost the chapter is completed. Now we are going to discuss some same points again for a recap. Do you have any doubts from previous class?
No, sir.
Okay. This is the quadratic equation ax square plus bx plus c. One root will be reciprocal of the other. Then if a is equals to c. So basically, what they are saying if there is one root alpha and if other root is 1 by alpha. So sorry. So the product of root is what? C by a. And the product in this case is 1. So further we can write it as c is equals to a. Clear?
Yes, sir.
Yeah. And if one root is 0, then it means the product is going to become 0. So that means c by a is 0. That means c is 0. Clear?
Yes, sir.
If roots are equal in magnitude but opposite in signs, like alpha and minus of alpha, so the sum of the roots is going to become, what will be sum of these two? Right?
0.
Yeah, alpha minus alpha will be,
Okay. 0.
so in this case, a cannot be 0 because it is in the denominator. B is going to become 0 for sure. If both roots are 0, then B, C should be 0. So the quadratic equation will look like this. So of course, x has to become 0 because a will not be 0 because it is the coefficient of highest degree variable which defines the quadratic equation itself. Okay.
Yes, sir.
Now discussing the next property. Roots are positive if a and c are of the same sign. B is the opposite sign. Okay, so A and C must be of same sign and B should be of opposite sign, then the roots are going to become 0. We have also discussed it earlier. Clear?
Yes, sir.
Something like this. Property number 6. Roots are of opposite signs if A and C are of opposite sign. If this will be, if one of C and A, one of C or A becomes negative, then of course the overall product becomes negative. And for overall product being negative, either of alpha or beta has to become negative. That's the logic. Clear?
Yes, sir.
Property number 7 says roots will be negative if A, B, and C are of the same sign. Clear?
Yes, sir.
Roots will be what? Tell me its roots. You have 2 minutes.
Sir,
Yes,
this
the product here should be 6. And the sum minus a
3x
5.
minus 5.
Ah,
3x and 2x.
roots will be minus 3 and minus 2.
Minus 3 and minus 2. But why is it x square plus 5x, sir?
Let me rewrite it. Like 5x. Uh, okay. So let me rewrite it for you. X squared, 5x can be written as 3x plus 2x plus 6 is equals to 0.
Hmm.
Taking x common, x plus 3. Taking 2 common, x plus 3. Now taking x plus 3 common. Here is x, here is 2.
Okay.
So now x plus
X is
3.
equal to minus 3 and minus 2.
Yeah, this is one.
Yeah.
Here,
Yes, sir.
now let's discuss about the common root of two quadratic equations. A1 x square plus b1 x plus c1 is equals to 0, and a2 x square plus b2 x plus c2 is equals to 0. So if the common root between these two quadratic equations is alpha, then the common root is going to become as c1 a2 minus c2 a1 divided by a1 b2 subtracted by a2 b1. So there's one trick which I used to follow is ka, ab, and 1221. 1221. Actually, coincidentally, I made this trick in 1221, December of 2021. Okay.
Sir?
So, like, first of all, we need to understand that if we have to find out the common root between the quadratic equations, and if there's such a root which is common between these two quadratic equations, then to finding out that there's this formula alpha is equals to c1a2 subtracted by c2a1 divided by a1b2 subtracted by a2b1. Now, yeah, now we can remember this formula using this trick. Let's first write ka, ab, then write 1221.
Okay.
That's a trick. And I also made this trick in 12 of 21, that is December of 2021.
December of 21.
Yeah.
Yes, sir.
Okay. So next, if both the roots of the quadratic equation are common, if like both of the roots are common, so this is the condition which has to be satisfied. If this condition is satisfying, then both of the roots will be common. Let's take one example, x square plus 5x plus 6, and another example. So both of the quadratic equation have roots -3 and -2, -3 and -2. So for this, for two quadratic equations having same roots, they must be proportional. Their coefficients must be proportional to each other. 1 by 3, 5 by 15 should be equal to 6 by 18. So 5 into 3, 6 into 3, which is 18. So 1 by 3 is equals to 1 by 3, which is equals to 1 by 3. Clear?
Yes, sir.
Absorb this slide for a moment. Done?
Yes, sir.
So that's the end of an easy chapter. Quadratic equations. Easy yet important. Okay. Any doubts from the chapter?
No, sir.
Okay. So remember, not always the quadratic equation will be in the form of x. It can be in the form of in place of x. It can be cos theta, tan theta, sin theta, or there can be such a quadratic equation which you can make out in, like, you can consider the variable as x or a or anything like that. Like we have already discussed about a quadratic equation like this. Okay, this is also a quadratic equation which can be considered plus 6, which can be considered as a quadratic equation in a or x. Clear? Clear?
Yes, sir.
Let me open other slides to practice questions. Is my voice audible?
Yes, sir.
Okay. Okay, so are you ready to practice questions?
Yes, sir.
Okay. Now I'm going to ask some formulas. So this is a quadratic equation having roots alpha and beta. So what is alpha plus beta?
Minus b by a.
What is b here?
B is b.
B is the coefficient of x.
Okay.
A is also coefficient, and C is also coefficient of x raised to power 0, and we can also say C is a constant here. So one more concept. Having three roots. So the sum of roots will be, please answer. What is this equal to?
C by
What is this equal to?
d by
Plus or minus?
minus d by a.
Yes. And how the cubic equation can be made from three roots? Like this. Going back, discussing about the quadratic equation. Now, please note the difference between these two. Okay, this is whole where students get confused and they mark wrong answers with different sign. So there's one more concept. If there is modulus, or if x is in modulus, है ना? So because there's no use of applying modulus on a variable which is having its square, because always going to become positive, right?
Yes.
So what is this? Understood? So I have written the signs of x and y in follow the quadrants. I'm referring to this. So so if quadratic equation is given in this format, okay, and we have to find out what are the number of real roots it's going to have, the number of roots it's having. So the trick 0, 4, 2, 2. Simple. The quadratic equation in this format, in spite uh, like disregarding the fact whether A, B, C can be any positive rational numbers, can be as any positive rational numbers. So there will be zero number of roots here for this quadratic equation. Zero number of real roots. Okay, 0 number of real roots here. For this, 4 number of real roots. For this, 2 and 2. So remember the signs I have written are in the format when we go from first to fourth quadrant. And also the signs I've not considered about AX. A is always positive. Okay. So please observe this slide. Rishi, why are you late? Okay. No problem if you don't want to answer. But please be attentive and sincere towards that. Is that clear?
Yes, sir.
Okay. Now the question, the previous year question, 2019 first NDA paper. The number of real roots for the equation. So this equation is in the format of first or second or third. This one or this one or this one or this one. Positive, positive everywhere. Positive, positive everywhere. So how many number of real roots will be there? How many number of real roots? Positive, positive, positive.
Mm,
0.
0.
Okay. Sum of three positive quantities can never, never, ever be 0. So the equation has no solution. This is also logical. Now let's discuss this question. Now it is given that the given quadratic equation is having 10, 19, and 26 as roots. Whenever we have something like angles, we are discussing about angles, and we have already known and discussed about the formulas of sum of angles and the difference of angles in the trigonometry. So please do one thing, that before proceeding, try to understand the correlation, the relationship between the given angles. 26 minus 19 is what? 7. 26 degrees plus 19 degrees is what? 96545 degrees. Yes. So if you take tangent on both sides, so this is going to become tan 26 plus tan of 19 divided by 1 by tan 26, tan of 19. Equals to tan of 45 is 1. Now we know it's a quadratic equation. So the sum of roots, which is these are roots basically. So the sum of root is minus b by a. What is, now please tell me what is the sum of roots here in this quadratic equation? What is
Minus
a?
p by 1.
Yes, very good. Very good. So this is minus p by 1. So this is the one root, this is another root. It's somewhere minus p. By 1 means minus p only. So 1 minus. Now please tell me what is the product of roots 2.
Q by 1.
Yes, that's q. So cross multiplying, minus p is equals to 1 minus q. And that will solve our question. So bringing q on the left hand side, q minus p is 1, which is matching with the option number A. Clear? Any doubt?
No doubt, sir.
Okay, so the equation where p, q, r are all positive has distinct real roots. Okay, so distinct real roots A and B. So now we have to tell about the nature of roots. So if they are all positive, we have already discussed uh, there will be both negative roots should be there, because in case of x square plus 5x plus 6, the roots were -3 and -2, right? So in this scenario also, a should be negative. Yes, a should be negative and b also negative. Clear?
Yes, sir.
Understood? And please do use this formula alone. I've done it multiple times to make quadratic equations for you to solve. I just take two numbers and make quadratic equation in this format. In this case, I have taken 2 and 3, minus of 2 and minus of 3. Okay, please make use of this formula and formulate quadratic equations by yourself. Okay, whenever the coefficients and constants are positive in quadratic equation, its root is always negative. Okay, what are the roots of this equation? So x square minus x minus of 6, x plus 2. So it's going to behave in two dimensions. When this particular whole function, let's call this as a f of x, when f of x is becoming negative, so this whole will be multiplied with a negative sign to make it positive. When f of x is itself positive, then it will remain the same. Do you understand?
Yes, sir.
Yeah. So let's solve it separatively. Let's solve the second statement first. So x squared minus x to the left hand side minus 2x minus 6 minus 2 minus of 8 equals to 0. Let's look for two roots which are opposite in sign because its product is minus 8. So it can be minus 4 and 2. Yes, minus 4 and 2 can be those two roots. So x can be minus 4, x can be 2. Now in this particular case, we are considering the f of x is greater than 0. So when x square minus x minus 6 is greater than 0, so it will be greater than or equal to 0. Uh, let's factorize this. So x square mm, minus of 3x plus 2x minus 6. Yes. Any doubts? Please ask if any doubt. How have I written so minus 3 plus 2x? Because when we multiply minus 3 and plus 2, it will give us minus 6. That's why I have conveniently done so. And also, when we sum minus 3x plus 2x, then it will give us minus 6. That's why. And that's why our factorization is also successful. So 3 here and minus 2 here. Correct. Correct.
Yes. No, -2 should be in that side and 3 this side also.
Yes. So this will be positive because the coefficient of both variable are positive, positive, negative, positive, and we know we need to make this function as positive. So we will only accept the values of x which are belonging to the minus of infinity going towards -2, and -2 will be included in this scenario because there's a equality condition which is existing. Unifying, also we will consider the value of 3 going towards positive of infinity. And minus infinity and positive infinity is never included because they are not defined. That's the reason behind that. Okay, so now this function to be positive, the x should belong here. Now we have find out the value on solving this further condition. We have find out the value of x as 2 and -4. So 2 is the if 2 is in this is 2 is lying in this particular domain. We are discussing about okay. We are discussing about this only. about the case when the function is becoming positive. So what we have done first is that we have taken the function inside modulus function and we have find it out the values of x for which this particular expression is going to become 0. So after finding out this domain, we have further gone on to solve the given equation, and we have found out the values of x minus 4 and 2. Now let us re-verify whether x is equals to minus 4 lying in this period is not or not. So we have included this area and this area. So minus 4 is will be lying here somewhere. So yes, minus 4 is there in the is there in the domain, right?
Yes, sir.
Hmm. What about x is equals to 2? Is 2 2 will be somewhere here. So this 2 is in the domain? No, right?
No, sir.
Yeah. So we'll not take the value of 2 here. So we have only find out a value which is x is equals to minus 4. Now let's discuss about the other condition. So this was x plus 2. Now what we are considering that uh, this particular expression x square minus 6 x square minus x minus 6 is going to become negative. So factorizing this further, let's take help from earlier calculations, drawing the number line. Wow, this is infinity, minus 2, 3, positive, negative, positive. Now this time we need all values of x lying between minus 2 and 3. And this time, minus 2 and 3 will not be included because there is no equality condition. Okay, so x will be lying between minus of 2 and 3. Now let's find out, now let's calculate this further. So if this is negative, so there will be a negative sign to neutralize the effect. Now let's bring this whole term to the right hand side. This cancels, becomes x square minus 4, this becomes x as plus minus 2. Understood why so? Understood why x will be plus
Yeah.
minus 2?
Yes,
Yeah.
sir.
Now let's re-verify whether this particular solution is verifying our earlier calculation, whether it is lying in the domain or not. Now please tell me whether do x is equals to minus of 2 is in the domain which we have find out. Please answer. No matter, like doesn't matter if you, even if you give wrong answer, that will be acceptable.
No, sir.
No, very good because it's an open interval.
Open
Minus
interval.
2 is not included because the the inequality's nature was strict in nature. It was not the equality is not was not included in our solution. So minus 2 cannot be our answer. What about x being plus 2? Is it in the domain?
Yes, sir.
Yes. So now we are going to consider how much values do we have found out yet. So for one is x is equals to 2, another one is x is equals to minus of 4. X is equals to minus of 4. Okay. So 4 and minus 2. minus 4 and 2. Okay. So there should be a minus 4 in the option, which is not the case. Let's re-verify our calculations. X square, that becomes minus 2x minus 8. So its root will be 4, and minus 2 can also be one number, 4 and minus 2. But yes, 4 and minus 2 will be the roots. Why? So let me explain. X square, minus 2x will be written as minus of 4x plus 2x minus it. And now remember, one thing I have mentioned earlier, that whenever the sign of here after factorizing, whenever the sign is negative, so it's the root sign of root will be of the opposite nature. So on taking x common, x minus 4 plus 2 x minus 4. So now it is clear that x is going to become 4, and other root will be x is equals to minus 2. So from here, minus 2 is lying in the given domain. So x is equals to minus 2 is the value which we are looking for. And 4 is also the value which we are looking for. Okay. And also we have find out earlier that x is equals to 2 is also a root of this particular equation. So option number D should be our answer. And yes, it is the case. So what we have done in this question, we have first discussed about the nature of root. So if this particular, let's call this as f of x, if f of x was becoming negative, we have modified the equation as taking a negative side out of the modulus function. And if f of x was positive or equal to 0, it's going to behave the same. And we have further gone on to, and now for this, there will be particular x domain, and there will be particular roots of x. So after finding its root, we have to reassure whether they are in the domain or not. If they are in the domain, we will consider that root. And for same goes for this. There will be certain domain here of for x, and there will be some roots from this particular equation. If the roots are reassuring and they are lying in the domain, then we are going to consider them in the answer. That's what we have done also. Understood?
Yes, sir.
Here,
Yes, sir.
so greatest integer function, we have also discussed its graph. Okay, so let's now, do you need any clarifications or more elaboration or explanation about greatest integer function?
Yes, sir, if possible.
Yes, of course, it's possible. It's about writing the greatest integer which is there in the given decimal number. So if we are if we are like we know on number line 0, positive of infinity, this negative of infinity. -1 is greater or -2 is greater?
-1 is greater.
Yes. And 1 is greater or 2 is greater?
2 is greater.
2 is greater. So it's the same. We are going to write the greatest integer for any number which is there present. We are not going to increase any number. So let's say for 1.2, what is the greatest integer present in this?
2.
No.
No, in that -1 or -2.
Let me re-explain. This is the number line. whenever we have any number. So let's first draw integers on this. Okay, there are integers on this particular number. So if there is like any number, wherever it is located, so what we are going to do is that we are going to approach that particular point from left hand side. And yes, we have reached. Now we are going to see on our path which is the nearest integer. Okay. Sorry, we are starting from the center, the origin. So now we have reached the point. Now we are going to look which is the closest integer. This is the closest. That will be our answer. And if there is like any number, let's say this is minus of 1, minus of 2, this is minus of 2.3. If we are going to approach minus 2.3 from the origin, now we are going to find out which is the integer which is closest to it. It's minus of 2. So minus 2 will be our answer. Here it will be 1. So minus 3.9, here it will be. So reaching minus 3.9, which is the integer that we have passed on our path, is minus 3. Okay. And it's about considering the like 3.9 can be written as 3 plus 0.9, and minus 3.9 can be written as, I guess I'm missing on something. Minus 3.9 can be written as minus 4 plus 0.1. Okay. And yeah, so it is the concept. Now let me rewrite it. First, absorb this. How have I written so? I've taken the fraction value in a positive manner. So, like, let me import the GIF graph, which is also known as this will clear all the concepts. Let me draw the graph. Okay. So this is the y-axis, that is f of x. This is the x-axis. Okay, yes. So the graph will be somewhat like this. There's one here, and there's one here, where one is not included, and one is included here. There's two here. So it means that for one, the greatest integer function is going to become one. For all the values from 0 to 1, excluding 1, the greatest integer function is going to remain as uh, as 0. So now discuss about these points. So this is there's a like closed node here. There will be a hole and node. Just minus 1. Then again, so now let's understand that for minus, let's consider this value. This is what? Minus of 1.5. For minus of 1.5, our greatest integer function is becoming minus 2. Okay. So yes, I was right that we were approaching from left hand side. Okay. And whatever was, whatever closer path was there for the, let's, let's write here only that, like for minus of, and this from this perspective also you can understand that a decimal number is represented in two formats. Say there's a x number decimal, so there is a greatest integer function plus a fractional form of that. So this is always going to become positive. This will be written from uh, range from 0 to 1. 1 is excluded, 0 is excluded here. Okay. So this has to be written either like either we have to write minus 4 or plus 3, but this will be positive. So that's also you can understand this is the greatest integer function. So let's take any example which you want. Please speak any number of which you want to find, of which you want to find me, which of which you please say any number for which you want to find me to uh, the greatest integer function. I'm blabbering in sentences only. Please speak any number. I'll tell you the greatest integer output. Go ahead. Take 1.08 and 2.5 and 2.5. So how minus of 1.08 can be written? First of all, its fractional value is this. Its fractional value is this. Its fractional value is this. Now, how minus of 2.5 can we find out? By writing minus 3 here, by writing 2 here, by writing minus 2 here. Okay. Have we done any mistake? Yes, we have. Here here there will be like 0.1. So also here we this it will remain the same here. Will remain the same here. Okay. So this is how it's going to be represented. This is the fractional value. This is the greatest integer value. Even if it is not clear to you, you can understand from the graph. The graph is this. There's a this value is included. Then there's a whole, and also you can search it on Google. And please understand the graph. Otherwise, there is also one more method that I have already told about the number line method, taking minus infinity to plus infinity, 0, and integers. So whatever number is there, of which you have to find out the greatest integer value, just approach that number from left hand side and look for the last integer which was there on your path. So the last integer, if you are standing here, So which is the last integer which was there on your path already, which is 0. Okay. That's how you'll be able to find out. Let's say this is -1, this is -2, this is minus of 2.5. If you have to, this is minus of 3. Now, if you have to approach this minus of 2.5, okay, approach. Now look for the nearest integer which was there on your path, which is -3. So -3 is going to become your greatest. Understood? So let's now go back to the question. This is wrong. -4 will be there. -3 will be there. Now let's discuss the question. So let x denote the greatest integer function. What is the number of solution of x square minus 4x plus this is the interval lying between 0 to 2. Okay. So I have to find out the number of solution. Let's find it out. For if the given interval is like this, so for x being 0 to 1 lying in this period, for x lying in 1 to 2 period, and for x being 2, there can be these scenarios, these conditions. So different excuses to join the club. Anyways, let's discuss for x being x lying in this period. So okay, x square minus of 4x for this particular period, the greatest integer is 0. So plus 0 is equals to 0. X is x square. So now x square taking x common, x minus 4 is equals to 0. Whether x can be 0 or x can be 4. No, x cannot be 4 for the given interval. So x cannot be 4. X is 0. So one root is x is 0. Okay. Let's discuss about this. In this for this particular period, x, the greatest integer of x is going to become 1. X square minus 4x plus 1 equals to 0. So product should be 1, and let's now find out its root using Sridharacharya formula. Minus of b plus 4 square root of b square is 16 minus 4a upon 2a. Okay, 4 plus minus square root of 12 by 2. So 4 plus minus 12 can be written as 4 into 3. So 2 into root 3 by 2. This can be further written as 2 plus minus root. Now root 3's value is 1.71. So 2 plus 1.71 is not satisfying with our given domain. But 2 minus of root 3 is 2 minus of 1.71. So is it going to remain in the domain? No, of course it's not going to, because it will be somewhat 0.3, which is not in the domain. So neither of roots are of use for us. Taking x is equals to 2. So for x is equals to 2, 4 minus 4, 4 into 2 plus its greatest integer is itself 2. So 4 plus 2, 6 minus 8 is not 0. So this is also not the root. So only one root is there, x is equals to 0. So answer should be B. Let's check. Yes, there is only one solution. This is also cannot become a root. This can also not become a root. Only root is this. So yes, these are the questions. Any doubt? Any doubt? Any questions?